Suppose a plane is flying on a heading of 60 degrees east of south at an airspeed of 165 miles per hour. The wind is blowing at 45 miles per hour from 25 degrees south of west. Find the plane's course and ground speed. So we're going to be applying our vectors here. So we've got one plane that's heading at 60 degrees east of south. So if I want to draw that in terms of a coordinate system, which I've already got started here, we want to make sure that we go south first and then east. So if we draw this, it looks like this. So we've got one angle here that's going to be 60 degrees. And of course that plane was traveling at 165 miles per hour. And then we have the wind blowing at 45 miles per hour from 25 degrees south of west. That's going to look like this. So this is going to be 25 degrees here. And we're traveling at 45 miles per hour. So we actually want to break both of these bearings up into its components. Now the problem with 60 degrees is that's a bearing instead of an actual standard. It's not an angle that's in standard position. So to make this thing in standard position, I want to think about, well, I've went all the way around to 270 and then I'm going 60 degrees more. So that actually gives us an angle that's 330. So when I go to break up my components for the 60 degree angle, I'm going to be using the angle 330 as its standard position. So let's split this up into our two different angles here. We got our 60 degrees, and then we're going to have our information for 25 degrees. And the problem with the 25 degrees as well, we can't actually use 25 degrees in the calculation because once again that's not in standard position. Standard position for that angle would be 205 because I went 180 and then I'm going 25 degrees more. So using our formulas, we're going to have the horizontal component is going to be equal to our magnitude, which is 165, times the cosine of, like I said, 330 degrees. And if we punch that in on the calculator, that's going to give us 142.89. And that's miles per hour. To find the vertical component, I'm going to do the same thing, except instead of using cosine, I'm going to refer to sine, and I'm still using that angle that's in standard position. So I've got 165 sine of 330 degrees. And that's going to give me negative 82.5 miles per hour. So let's do the same thing for 25 degrees now. We're going to have our horizontal component is going to be equal to the magnitude, which in that case is 45 degrees, times, once again, it's going to be the cosine of 205. And if we punch that in on the calculator, we get negative 40.78 miles per hour. And let's find the vertical component. So V sub y is going to be equal to 45 sine of 205 degrees. And that gives us negative 19.02 miles per hour. Now we want to actually add the horizontal components together, and likewise we're going to do the same thing for the vertical. So if we take our horizontal components, which is this value and this value, and add those together, we get a grand total of 102.11 miles per hour. So our horizontal is going to be 102.11. Let's find our vertical. So if we combine our vertical components, and that would be this one and this one, that's going to give us a grand total of negative 101.52 miles per hour. Now we can create a new triangle with our combined components. So let me go ahead and sketch this. So we're going to have 102.11. And then, of course, we're going to go down to negative 101.52. So we've got a triangle that's going to end up looking like this. So we'll call this A and this B. And the first thing we want to do is we actually want to find the resultant. So to find the resultant, we're actually going to use the Pythagorean Theorem. So I'm just going to do 102.11 squared plus negative 101.52 squared, and that's going to be equal to C squared. So if we square those things and add them up, we get a big number. It's 20,732.7625 equals C squared. I want to take the square root of both sides, and if I finish that calculation out and round it to the nearest hundredth, I actually get 143.99 is going to be equal to C. So that's the plane's ground speed. Of course, this is in miles per hour. So now we want to find its course. We can do that by actually using tangent of theta. It's going to be equal to, now remember, tangent is equal to opposite over adjacent. So the opposite side, since this is the angle I'm looking for, is going to be negative 101.52 divided by 102.11. So tangent of theta is equal to negative 0.9942. And I can solve for theta by finding the arc, or by taking the arc tangent to both sides. And if I do that, I'm left with theta equals negative 44.83 degrees. So once again, this information is not our standard position. We want it to be in standard position. So to do that, we want to make it in terms of starting from 0. So if I add 360 to this angle, I get theta, or this angle is actually equal to, because I want this one. So theta is actually going to be equal to 315.17 degrees.